Welcome to Algebra 2, Unit 7, Lesson 7, Practice Problems. We're going to start today with the vocabulary terms, the first of which is normal distribution. This is a specific distribution in statistics whose graph is symmetric and bell-shaped, has an area of 1 between the x-axis and the graph, and has the x-axis as a horizontal asymptote. If you notice, the mean in the first and second is 10, and then in the third is 8. So you notice that the difference is that this bell shape shifts to the left to match up with the mean. You'll also notice that the standard deviation in the first one is 1, but it's 2 in the second and third. And also notice that the larger the standard deviation, the wider this bell shape is. So what you really need to pay attention to is that it must be symmetric and bell-shaped, and that it has an area of 1. And the other vocabulary term is a relative frequency histogram. This is a histogram where the height of each bar is the fraction of the entire data set that falls into the corresponding interval. That is, it is the relative frequency with which the data values fall into that interval. So the difference is that this is a relative frequency histogram and not a regular. So instead of keeping track of the number of times that a data point shows up, now you are tracking the proportion of the time, or a percentage of the time that a data set shows up. So in our first practice problem, it says, when Lynn drives a golf ball, it travels a mean distance of 200 yards with a standard deviation of 20 yards, and the distribution of lengths is approximately normal. Approximately what percentage of her shots will travel less than 180 yards? So it might help if we draw a diagram here. So we're going to have the bell-shaped curve, and they told us the mean distance is 200 yards. So that will be the center. And then they told us the standard deviation is 20. So if we go one standard deviation below, we are at 180. That's minus 1 standard deviation. If we go one standard deviation above, that's 220. And we need to think back to our 68, 95, 99.7 rule. Because what we know is that between one standard deviation below and one standard deviation above, this would be 68% of all data points. So now that means if we have 100% under the entire curve and we just accounted for 68%, that leaves 32%. But now this needs to be divided between being below 180 and being above 220. So 32% divided by 2 equals 16%. So that means below 180 there is 16%, and above 220 there is also 16%. So our final answer is that 16% of her shots will travel less than 180 yards. If you have any questions about how to answer a question like this, be sure to use class time to ask for clarification before we have our next test. Next practice problem. A distribution is approximately normal with a mean of 18 and a standard deviation of 4. Match the interval with the approximate percentage of data that falls within that interval. So again, it's always good to draw a quick sketch so that you know what you're talking about. So I'm going to draw an approximately normal curve. We know that the mean is 18, and we have a standard deviation of 4. So that means minus 1 standard deviation would be 14, minus 2 standard deviations would be 10, and minus 3 standard deviations would be 6. And if we go the opposite direction, then 1 standard deviation above would be 22. 2 standard deviations above would be 26. And 3 standard deviations above would be 30. So, first, I'm going to look down here at numbers 6, 7, and 8, because those are the rule percentages. We know that 68% is going to be between 1 standard deviation and below and 1 standard deviation above. So in this case, that's 14 to 22. So F matches number 6. Next, 95%. We know that this is between 2 standard deviations below and 2 standard deviations above. So that would be from 10 to 26. That matches E, so E matches number 7. And then finally we have the 99.7, which is 3 standard deviations below to 3 standard deviations above. So that would be choice B, between 6 and 30. Matches choice 8. So now we've got to look at some of the other ones. So if I wanted to know less than 10, then that is below 2 standard deviations. So if I have 95% between 2 standard deviations below and 2 standard deviations above, then 100% minus 95% equals 5%, and 5% divided by 2 equals 2.5%. So A matches number 1. 2.5% would be less than 10, and 2.5% would be above 26. Next, we have between 10 and 14. Well, we know that from here up, we've got 68% plus the 16% that would be above it. So that equals 84%. So that means there's still 16% below. But we know that less than 10 was 2.5%. So we need to do 16% minus 2.5%. That leaves 13.5%. So C matches number 2. Our next one is between 10 and 18. So if the mean is 18, that means 50% is above 18. So now we're down to 15% left. If we know that 50% is above 18, and we know that 2.5% is below 10, then that's 100% minus 52.5%, leaving 47.5%. So D matches number 5. Now if we look at G, we want between 18 and 22. So this time, kind of in reverse, we know that 50% is below 18, and we know that 16% is above 22. So now we're going to have 100% minus the 66% that is below 18 and above 22. So that leaves 34%, so G matches number 4. And finally, H, we've already said that above 22 is 16%. So that means H matches number 3. If you have any questions about how to use the normal curve rule 68, 95, 99.7 to answer questions like this, then please use class time to ask for further clarification so that you are prepared for the test. And our last practice problem, Tyler looks at this histogram of a distribution with a mean of 6.7 grams and a standard deviation of 1 gram. He claims that approximately 68% of the data is between 5.7 and 7.7 grams. What is the error in his thinking? The problem is what I highlighted in the definition. Normal distribution and the 68, 95, 99.7 rule can only be used with symmetrical bell-shaped data. This is what we call skewed left. Because the tail is to the left while the majority of the data is to the right. If you have any questions about any of the practice problems from Lesson 7, please use class time to ask for clarification so that you are completely prepared for the next test.